The title of this video is A Method for Recovering Oil from Water. I will describe this method by referring to a couple of drawings. The first drawing shows oil that has been skimmed and is contained within a skimmer. This skimmer is attached to two boats that move the skimmer toward a barge. As the boats move along each side of the barge, the skimmer moves up the ramp that is extended from the top of the barge to a few feet below the water surface. The next drawing is a cross-section of the barge that shows the skimmer on the ramp, two baffles that are located inside the barge, and a pump that is located in the bottom of the barge. As the boats continue to move by each side of the barge, the skimmer moves to the top of the ramp and deposits oil and water into the barge. The skimmer then moves across the top of the barge, down a ramp, and back into the water. The oil and water that are deposited in the barge fall on the top baffle, run down this baffle, seep through holes onto the lower baffle, and then into the barge itself. These baffles prevent the oil from momentarily sinking below the surface of the liquid in the barge. The top of this liquid is maintained at or slightly above the lower baffle. As skimmers continuously deposit oil and water into the barge, the pump continuously pumps water out of the barge. To prevent the oil layer from reaching the pump, there is a sensor that stops the pump when the bottom of the oil layer reaches a given point. This process does not need special equipment to separate the oil and the water. This separation takes place naturally because oil floats on water. These drawings illustrate the basic concept of this process. However, on a large scale, several barges would be connected to one another to create a recovery station. This mock-up, which consists of 6 barges that are connected to one another and has ramps on opposite ends, is an example of a large-scale recovery station. As the skimmer moves up the ramp, deposits oil and water, then moves across the top of the recovery station, another skimmer can begin to move up the ramp. Since the skimmers return to the body of water by moving down a ramp on the opposite end of the recovery station, skimmers can continuously deposit oil and water. The pump is continuously pumping water out of the recovery station. The news media has stated that there are 600 to 6,000 boats working in the Gulf of Mexico. 1,200 boats could be used to form 600 skimming units. This many skimming units can simultaneously skim a large body of water. If these skimmers are 400 feet long, and each one deposits oil and water into a recovery station every half hour, these skimming units could process about 7,200,000 gallons of water per day. Now I will demonstrate this process. This pool represents a body of water, and these rods represent 2 boats that will move the skimmer up the ramp and deposit oil and water into the barge. The barge contains a siphon that siphons water from the bottom of the barge. To simulate a skimmer that has skimmed some oil and is approaching the barge, I will pour some oil between the skimmer and the barge. To simulate the boats moving the skimmer up the ramp, I will pull the rods to move the skimmer up the ramp and deposit oil and water into the barge. As you can see, no oil is lost as the skimmer moves up the barge. This is a view of the oil and water that has been deposited into the barge. This is a view of the clear water as it is siphoned from the barge.